and welcome back. This is a part 1 video discussing 4 exercise questions on galvanic cells. Let's get started. First exercise. For the cell below, write the half cell equation at anode and cathode as well as the overall cell reaction equation. Here, what is given to you is the cell notation. You must recall that the cell notation is written in the format of A, B, C, which stands for anode, bridge and cathode. So, the process that is occurring at anode would be oxidation, that would be conversion of zinc solid to Zn2 plus aqueous with the release of 2 electron, that must be written at anode. And as for cathode, Cr3 plus aqueous taking in 3 electrons will be converted into Cr solid. So, we have answered the first part of the question whereby we are writing the half cell equation for anode and cathode. For the overall cell reaction, you must make sure that the electrons on the left hand side as well as the right hand side of the equation is balanced. So, looking at the value 3 and 2, the lowest common multiple would be 6. Therefore, for the first equation, we must multiply it by 3, and for the second equation here, we must multiply it by 2. By doing this, the electrons on the left and the right can be cancelled, giving you the overall cell equation that would be 3 Zn solid plus 2 Cr3 plus aqueous to produce 3 Zn2 plus aqueous and 2 Cr solid. Make sure to write your physical states, that is very important. Now, let us move on to the next question. Exercise 2. Write the cell notation for the Voltic cell at standard condition that incorporates the following redox reaction. Here in question A, B and C, you can see that the overall cell reaction is given. So, in order to write cell notation, firstly you have to identify the oxidation half reaction. Next, identify the reduction half reaction. Why do you have to do it? Because oxidation occurs at anode, whereas reduction occurs at cathode. This is important because the cell notation is written in the format of A, B and C. Now, let us look at the answers and understand better. So, for question A, oxidation is occurring from aluminium solid to aluminium 3 plus aqueous. For reduction, it is from Cr3 plus to become Cr. Therefore, in order to write the cell notation, we are going to start with the anode end, which is aluminium solid converted into aluminium 3 plus. Place a straight line in between aluminium solid and aluminium 3 plus to indicate the difference in phase. Aluminium 3 plus is in aqueous phase, and make sure to write the concentration along with it. How do we know the concentration? The question says it is in standard condition, therefore, concentration of solutions at standard condition would be 1 molar. Next, place 2 straight lines to indicate bridge. Finally, moving towards the cathode end, it would start from the aqueous Cr3 plus being converted into Cr solid. Because there is a phase difference between the aqueous Cr3 plus and Cr solid, we will be placing a straight line in between them. Here again, the aqueous solution of Cr3 plus has a concentration of 1 molar since it is at standard condition. For question B, we will be doing the same. Aluminium being oxidized into aluminium 3 plus and iron 2 plus is being reduced into iron. So, let us start by writing off the anode end, which is aluminium solid converted into aluminium at aqueous state with concentration of 1 molar since it is at standard condition. Make sure to place a straight line between them to indicate phase difference. Next would be our bridge, and moving on to the cathode end, it would be Fe2 plus aqueous with concentration 1 molar converted into Fe solid. Again, place a straight line to indicate the phase difference. Also, do take note that there is a comma placed in between of the aqueous as well as the 1 molar concentration. The next thing that I would like you to notice is that our overall equation has got stoichiometric coefficients. However, the cell notation does not include the stoichiometric coefficient. This is very important. Please do not include the stoichiometric coefficients into your cell notation. Now, let's look at question C. Again, we are going to start off by identifying the species that is being oxidized, which is our cobalt, and the species that is being reduced, which is our H+. So, start your cell notation by writing the anode end, which undergoes oxidation reaction. So, cobalt solid, a single line with cobalt aqueous with concentration of 1 molar, place double line in the middle to indicate bridge, and this is our salt bridge. Next would be our cathode end, which is H+ aqueous, concentration 1 molar, separated by a single line again to indicate phase difference and being converted into hydrogen gas. So, here you must take note that hydrogen gas at standard condition would have a pressure of 1 atmosphere. Please include that in your cell notation as well. The electrode that is used for cathode, which would be a platinum electrode. So, make sure to use a straight line in between the hydrogen gas and the platinum electrode, which is solid. Now, let's go on to the next question. Exercise 3. Write a balanced chemical equation for each cell notation. In order to write a balanced chemical equation, we require the half equation at anode, the half equation at cathode, and combining these two together would give us the overall chemical equation. So, from a cell notation, we are able to retrieve this information as the cell notation is written in the format of A, B, C, whereby it is anode, bridge and cathode. So, anode is where oxidation reaction happens, and we should be able to write the half equation for that, and cathode is where the reduction reaction occurs, and we should be able to write that as well. So, let's look at the answers. So, for the first question, the oxidation was from Mn solid to become Mn2 plus, and the reduction reaction was from Cd2 plus to become Cd solid. Since the electrons on the left hand side as well as the right hand side is balanced, therefore, we can combine both the equations to give us the overall equation. For the next question, it was magnesium that is being oxidized into magnesium 2 plus, whereas at cathode it was Se3 plus being reduced into Sc. Here, the electrons on the left hand side and the right hand side are not balanced, therefore, we should balance it by identifying the lowest common multiple, which would be 6. Therefore, the first equation is multiplied by 3 and the second equation is multiplied by 2. So, this would give us 6 electrons, and the electrons on the left and the right can be cancelled, giving us an overall chemical equation, which is 3 Mg solid plus 2 S3 plus aqueous to produce 3 Mg 2 plus aqueous plus 2 Sc solid. Make sure the physical states are written for all 3 equations, which is for anode half equation, cathode as well as the overall, and don't forget your stoichiometry coefficients as well. Now let's move on to the last question in this video. In the following cell notation, you are required to draw a Voltic cell, write the anode and cathode half reaction and the overall reaction for the following galvanic cell. So here the cell notation is given. So again I am reminding you that a cell notation has the anode half end and as well as the cathode separated by a salt bridge. So from there we should be able to write the anode half equation as well as the cathode half equation. As you can see over here, the anode half equation is written with the balanced number of electrons with the cathode. Okay, prior to this you can write the original half equation that is happening at anode, which would be Al converted into Al 3 plus. Don't forget your physical states. And for cathode, from here you can do the balanced version of the half reaction at anode and cathode. The overall reaction is given as shown. Next would be drawing the Voltic cell. What are the key things that you have to make sure that is in your drawing? First would be the correct electrode and their solution. Make sure to label them both for the anode end as well as the cathode end. Make sure to label the anode end as negative terminal and cathode end as the positive terminal. Include a salt bridge and also indicate the electron flow direction. Since it is a Voltic cell, make sure there is a voltmeter in the middle. That's all for part 1 video. I'll see you in the part 2 video discussing more questions on galvanic cells. Thank you.